Today, what you guys are doing is basically doing some math with a new formula, new concept, but basic gist of it is objects traveling around a circle will have a couple different factors that you need to take into account. One is the acceleration. When an object travels around the Earth, like the space station, the acceleration that is keeping the object orbiting is Earth's gravity. That is the acceleration that is keeping the object from just flying off into space. While it is traveling, it is also going to be having a certain speed, known as the tangential velocity. Tangential velocity just means when an object is in a circle, there is going to be a speed that is traveling at that is perpendicular to the radius of its orbit. So here's the radius, here is the VT. Tangential speed, like all it is essentially is it's a perpendicular line to the circle. It only intersects at that point is the idea. Don't stress too much about understanding it, but if you just think about it as a object traveling around in a circle will have a speed. That speed is your tangential velocity. All right. Now, we're just going to jump right into some questions just so that y'all can jump into the worksheet. This one, we are given a couple things. So we have a Ferris wheel traveling at a tangential velocity of 4.5 meters per second. So in this case, we give it VT is 4.5 meters per second. Its radius is 31 meters. And what is the centripetal acceleration of the Ferris wheel? All right, so we are looking for the AC. The good thing is, whenever you see the word centripetal acceleration or tangential velocity, you can basically assume we are using this formula, and we can just double check. We got AC, yep. We got VT and R, yep, and yep. Very easy, nothing too crazy. There's just three possible variables. So from here, we just plug our numbers in. We have AC is equal to 4.5 squared divided by 31. The only thing that most people, if they make a mistake on this, will do is they will forget to square the top number. So please make sure you do that. And I'm going to check what that is. There we go. And the answer is 0.65 meters per second squared. All right. Now, let's move on to the next one. A pitcher throws a softball with a centripetal acceleration of 1,400 meters per second squared. The length of her arm is 0.8 meters. What is the tangential velocity of the ball? Now, just so that you guys are aware, I did give y'all the notes the other day. Not all of these questions are the ones that we are going over today. But for your own sake, it might be a good idea to check your notes and go through the extra ones I don't get to during this little note section. All right. So a pitcher throws a softball with a centripetal acceleration of 1,400 meters per second squared. The length of her arm is 0.8 meters. Now, this is a tricky part. So, AC is 1,400 meters per second squared. If we have a person, they're standing here, they are spinning the ball around in a circle. The thing that is keeping the object traveling in the circle is that person's arm. So, in this case, the radius from the center of the object to the edge of the object is actually the length of her arm. That is our actual radius value. So when you're doing these problems, sometimes you'll see a thing where it'll be like an object is traveling around a track with a diameter of something. For those questions, just make sure that you remember how to find radius from the diameter. But in other situations where it's spinning around a central point, whatever that object is that is spinning around, like the arm, or if you're spinning something on a string, that would be the length of the string, will just simply be your radius. Okay, so in this case, her arm is the radius, and that means we can solve this question. All right, so continuing from here, tangential velocity is my unknown in this case. Still going to use the same equation. Nothing changes from here. All right, and then we're going to go ahead and plug these in. So 1,400 equals VT squared. VT is my unknown. 0.8 is the radius. So to solve for this, these cancel out. And 1,400 times 0.8 times 0.8 is 1,120. It's equal to VT squared. And to get rid of the square, we gotta square root it. So I'm going to go ahead and do that. So we square root that number and we get an answer of 33 point, I'm going to round it, 5 meters per second. And that's it. So that's how you do those types of problems. That should help you on a portion of the worksheet. And last type of question you may see related to these this topic is something like this. While driving on Toad's track, Mario drives up to a curved section. He is traveling at 20 meters per second and experiences a centripetal acceleration of 4 meters per second squared. What is the radius of his turn? All right. So our given values, we have 20 meters per second. That means that it has to be our speed, aka our velocity. And since we are traveling around in a circle, that means that that speed is my tangential speed. All right. The centripetal acceleration is 4 meters per second. It tells us right there, 4 meters per second squared. And then the last thing that we are looking for is the radius. All right, again, same equation. And from here, we just got to plug things in. AC is 4, VT is 20, and then R is our unknown. So the way to solve this, the 4 and the R switch places. Oh God, I have to sneeze. It passed. Okay. I'm in so much pain right now. All right. So we have R equal to 100 meters if you plug it into the calculator, because 20 squared is 400 divided by 4 means we get 100 meters. And that is it. So basically, I gave you all the 3 different types of ways that you can solve one of these questions. There is one bonus question on the worksheet that you will notice. So if you have to go back through this video to just kind of like figure out some things, go for it. Other things to note just while you're doing this, just be careful on the units and read questions carefully. They give you a bunch of hints on how to figure this out. Also, one thing that you will need for the worksheet is there's a formula of V is equal to your distance over your time or your displacement over your time. So that will help you on a challenge question. So that you will need to be able to figure out one of the questions. So with all of that in mind, I'm going to go ahead and leave it. Try your best on the worksheet. Finish the whole thing. I know there's a weird question on the front about like these like forces and stuff, and they have different numbers. Just try your best on this one. We are going to learn about this later, but I really think that y'all can figure it out. Just a hint, you have to make another triangle using the remaining arrow sizes. So think about all the things we've talked about with if we're going in opposite directions for displacement, we would have to either add or subtract. If we're going the same direction, we have to add or subtract. Keep those things in mind when you're solving this question. It's kind of a bonus, but I think you can do it. All right. That's it. Have a great day. Enjoy your weekend plans, whatever you have that you're going to do. And I'll see y'all next week. All right. Bye.